Hello, class. So we are in section 2.3, which this is the last section that you have to know for test 1. Okay, so you will not need to know section 2.4 for test 1. Okay, this is the last one. And this should be a very short section, but I find that even though there's not really much to talk about, that doesn't stop many students from being very confused. Um, so this is getting information about a function from its graph, okay? So first, I'm gonna talk about domain and range again, okay? So hopefully by now you notice that these topics are never going away. Like you should hopefully understand domain and range, okay? But domain is all the possible x values, okay? And range is all the possible y values. All right, so you should be able to know each. Okay, so I'm gonna call it purple. Okay, so here I'm gonna recall from last section we have the square root function. Okay, and if you remember, it looks like this. Okay, so if I have this function, I should be able to stare at it. Okay, and right, the arrow means it goes off forever, right? So if I look, right, like if I kind of like trace it down or project it onto the x-axis, right? My graph is above this, right? No. Okay, close enough. So yeah, this part. And you notice like there's no graph here. So the domain is 0 to infinity. Okay? And then I can do the same thing with the y-axis. Like where is my function? It starts here, and then right, it's going up forever, right? Like eventually. So it's all of this. Okay? Okay. So the range is also 0 to infinity. Right? And hopefully this is clear from the picture, but also like right, you know the square root function, right? You know you can't plug in negative, so this should be the domain and you should know it. And then range, you know that you should, like when you plug in stuff, it'll be positive, right? So another example, okay, I'm going to talk about this function. So x squared minus 2. All right, let's just do minus 3. Okay. So I'm going to draw this for you. Okay, you don't have to know how to draw it yet. It's going to be here, and it's going to look like a parabola. Okay. So again, I'm going to look at the x-axis and be like, where do I have function? Okay. Everywhere, right? Like, because this goes on forever in both directions. Okay. So the domain of this function is negative infinity to infinity. Excuse me, parentheses always on those. Okay. The range though, if we stare at this thing, we're like, okay, so we get all of this, but then like we notice, right? Is there ever gonna be a piece of the function down here? Like no, right? Because this goes up forever and this goes up forever. So I will never be down here. So the range is, right, this is -3. So it's bracket -3 to infinity, right? Because I start down here and then I just go up forever. Okay, so I hope you can see the domain and range, like literally see how I'm getting these numbers. Okay. And then let me just make up some really weird example. Okay, so like this, I don't know what this function is. I'm just making it up. Okay. So it's going to go like this. It's really weird here. And then just like, boom. Okay. So if I call this point, I don't know, 25, and I call this point -10, and down here, -7, and up there, oh, this is like really up there. Up there, like 17. Okay. And this is where, like, right, there's no arrows. Okay, so this is it. It just stops. Okay. So I hope you can see the domain, right? The domain would be this. So the domain is -10. Well, I could put an open circle. Open circle. Let's be a little interesting. Open circle. So the domain would be -10 bracket 25. And the range would be -7 parentheses 25. Sorry, excuse me. Okay. Because, right, I'm not actually allowed to be this, right? This is a whole. Okay. So yeah, not that hard, I hope. Okay. Just, involves a lot of staring. Let me see if, can I do this? Like, what if I take this? I'm gonna see if technology likes me. So the function, and if I just, nope. Never mind. My cool idea does not work. Okay. I was gonna be like, well, if you just squish this all into the y-axis, it becomes this red line. That's another way to look at it if you're having problems. Okay. But okay. So that's domain and range. Okay, hopefully that's not that complicated. What is a little bit more complicated, and really you need calculus for this, but we're not going to talk about that. Okay, increasing, decreasing, and constant. Okay, so you should be able to know when things are increasing, decreasing, or constant. Okay, so I'm going to write down the math definitions. Increasing, decreasing, constant. Okay. So okay, when you're moving along your function, so you're going like left from right, okay? So if you're following along with your function, okay, a function is increasing if you basically are going up. Okay, so if f of x1 is less than f of x2, okay? But a function is decreasing if when you're following along, f of x1 is greater than f of x2. And then this one's probably the easiest, but a function is constant if when you're following along, you're not going up or down. You're just staying where you are, okay? So let's talk about a graph. Okay, here's an example. So here I have the function 12x squared plus 4x cubed minus 3x to the fourth. Okay. And it looks like this. Okay, so 0, 0. It's going to be a little difficult for me to draw. Okay, so it looks like this. And let me label some important points. So this point right here, -1, 5, that's 0, 0. The top of this thing is 2, 32. Okay, so that means this is 2 and this is 5 and this is -1. Okay. All right, so something I always say to my classes, and I don't know if it actually helps or not, but the x coordinate, okay, so the x, right, the x values is where you are. Okay, so when I think about x, I think about location. Okay, which is different than y, because I like to think y is what you are. Okay, which is not a location, right? That is a value. Okay, so I don't know if those things are going to help you or not. If they do help you, great. If they don't, you can just ignore them. Okay, but so you want to know where you're increasing and decreasing. Okay, so if I stare at this, so if I follow my function from left to right, I'm going up, I'm going up, I'm going up, up, and then I hit this dot, and then I stop going up. So I am increasing on this chunk. So increasing from negative infinity to -1. And then what happens, right? So then at this dot, I actually start going down, right? Until I hit this dot. So from here to here, from -1 to 0, I am decreasing. And then just kind of continue. So following along, I'm going up, 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 up. So from 0 to 2, I'm increasing. And then after here, I go down forever. So after 2, I just am decreasing forever. Okay. So these intervals, this is where I am increasing and decreasing. Okay, I hope that helps. Okay, but the other questions you're gonna get are, what are the maximums and minimums? Okay, so I don't know what your book likes to call it now, but they're either called local maximums or minimums, or relative maximum minimums. Okay, so they either use the word local or relative, but basically, you can also just stare at this and find out, right? Like this dot 0, 0, that looks like a minimum, right? Because like if I roll a ball down this hill, it'll like do this until it gets stuck in the middle, right? It's the minimum, or it's the bottom of like this trough. Okay, so the min, okay, is at x equals 0, and the minimum value is 0, okay, which is the y coordinate. Okay, that's why. So where is it? 0. What is it? Also 0. Okay, so the local min is the 0.00. Okay, so these are like many ways to ask the same question. Okay, but now let's talk about the maxes, right? So we have 2, right? I hope you can see them, right? It's the top of these hills. Okay, so we have local maximums at x equals -1, 2. Okay. Or local maximums are -1, 5, 232. Okay. But the maximum value, okay, depending on which max you're talking about, the maximum value is 5 and 32. Okay. And then this is not part of the class, but if you wanted to talk about absolute maximum, it would be 32 because that's the biggest number. Okay. But that's not important. Okay. So yeah, you should be able to know a lot of info just from staring at the graph. Okay, you can like dissect its pieces and know things, okay? So now I'm gonna kind of make one up just to talk about increasing, decreasing, constant, okay? So here is a graph, okay? I have no idea what the function is, okay? But it's gonna start at 0, 0. We're gonna go up and then down and hit there, and then we're gonna do this, and then we're gonna go up again, down again, up forever. Okay. And I'm gonna have to label some stuff. So let's just go like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's call this one 13, 14, 15, 16. Okay, that's all I care about. Okay. So and the y values I actually don't care. Okay. So we should be able to know where we're increasing, decreasing, and constant. Okay, so again, we always go left to right. Okay, so we're going to start off increasing until we hit the top, right? And then this is a max, right? This is a local max. Okay, but so from 0 to 3, I'm increasing. Okay, then we notice I start going down until 5. So from 3 to 5, I am decreasing. And then this happens. I'm just flat, right? I'm not going up or down. So this means from 5 to 11, I am constant. Okay, so constant means flat. And actually, so what that means is this right here, both of these points, these are not local mins. Okay, it's a little complicated to explain why, but basically because like if this was a minimum, then this point should be a minimum, then this one should be a minimum, then like the whole line should be a minimum, and then like we kind of like lose the importance of the word. Okay, so constants kind of break the min-max things. Okay, but as soon as we hit 11, we start going up again, and we go to here, which I call 13. So from 11 to 13, we are increasing again. And then from 13 to 16, I start going down. 13 to 16. And then after 16, I go up forever. So 16 to infinity. And that is where my function is increasing, decreasing, and constant, okay? And we actually have a max here, so a local max, okay? And down here, we have a local min. All right? So hopefully not too difficult, all right? It's very hard for me to test you on this, like online especially. So don't expect, you don't need color pencils for your test, all right? Definitely, maybe like what is the max, or find local maxes and mins. That's probably a more common kind of question. But I could ask you increasing, decreasing, and interval notation. Okay. But yeah, that's pretty much it for this section. All right, really short, really quick. Just stare at a graph, okay, and be able to talk about it, right? Be able to learn from it, and tell me its information. All right. That's it for this section, guys. So this is all that's up to test 1. Okay, so review the last couple sections, and you can officially do all the questions on your study guide. Okay, so I encourage you to look at the study guide, and see you next class.